and my findings on homework 1 and word analogy performance using word-to-vec embedding. I trained custom models on Wikipedia data and compare them against pre-trained glove embedding. My analysis focuses on how pre-processing choices and corpus selection dramatically impact performances. So the model configuration, I used word2vec with CBEL algorithm and 100-dimensional vectors and 5-word context window. And the pre-processing pipeline included lower casing, stop word removal, and lens filtering. Quickly, I tested both with and without lemmatization, which turned out to be a key decision point, as I will see. I trained these models using 5%, 10%, and 20% of Wikipedia's 5.6 million articles. The result shows clear vocabulary growth from 415,000 to 992k words, but with diminishing returns. The 10% model achieved 64.5% semantic accuracy compared to 66% for the model using 20% of data, suggesting it's the optimal balance between the performance and the computational cost. Doubling the data only added 2% accuracy while doubling training time. Okay, let's discuss about the corpus comparison. So I compare Wikipedia trained models against one trained on AG News articles. The result was striking. The news model achieved only 8% accuracy versus Wikipedia 66%. The news corpus learned temporal, event-specific associations. For example, kins become associated with Cambodian royalty from recent news coverage rather than general monarchy concepts. This demonstrates that corpus diversity matters more than sheer size. Sorry. Sorry. News models are 37% out OOV, sorry. Out of vocabulary rate shows as simply lack the breadth needed for general analogy task. Finally, we want to discuss about word similarity analysis. So examining word neighborhood using reveals how context shapes embedding, like doctor in the news model associated with medical emergencies, leukemia treatment hospital, while Wikipedia linked to the professions like surgeons and psychiatrists. Kin show the most dramatic differences. Glove and Wikipedia link it to prince and queen, but the news model linking specifically to Cambodia's Kim Shinamoni. I don't know who he is, whatever, who was frequently in the news during the training period. So this is our critical findings. So I discovered two critical preprocessing issues. First, a capitalization mismatch caused 51% of predictions to fail initially. The dataset used Athens, but glove only had Athens without a capital in its vocabulary. This caused O geography category to have to show 0% accuracy until I implemented lowercase normalization. Second, lemmatization completely destroyed morphological patterns. With lemmatization, plural detection was 0%. The model literally couldn't distinguish car from cars because both were converted to car during training. Retraining without lemmatization recovered 65% plural accuracy and improved overall syntactic performance by 10% points. This shows that preprocessing choices have consequences beyond just vocabulary size. Finally, want to visualize the so-called TSNE visualization. So quantitative analysis of TSME plots revealed interesting clustering patterns. The custom model achieved a positive silhouette score of 0.06 versus Globe's negative minus 0.07, so indicating better defined gender clusters, male female turns separation was 55% stronger in the custom model, with a center distance of zero point 0.4 versus zero point 0.3 for Globe. Despite training on less diverse data, Wikipedia's encyclopedic coverage of family relationships produce more semantically organized embedding for this specific domain. So, three key takeaways. First, avoid lemmatization for general purpose embeddings. It provides vocabulary, vocabulary efficiencies, but it destroys morphological information. Second, but it really depends on your use case. Yeah. Second is to use large, diverse corpora like Wikipedia for general NLP tasks. Specialized corpora like news work only for domain-specific applications. Finally, the 10% sampling ratio offers the best cost-benefits balance in this data set and in this specific task. Finally, always validate pre-processing consistency between training and evaluation data. Subtle mismatches like capitalization can masquerade as model failures. Thank you for listening, and the code will be submitted to GitHub after the deadline of this homework assignment. Thank you.